Isn't that a burlesque show?
You do not want to see me do burlesque, man. My name's Alice. I'm a local Portland author. My day job, I'm a programmer, but I wrote this book, The Fork, that's up here. It's a post-apocalyptic novel about what it's like to actually survive in a broken city, like well after the apocalypse, and how you might go about rebuilding things. So what I'm really interested in as an author is how humans interact with the environment and how environments interact with each other. So how does the natural world run up against the built world, and how do you navigate those intersections? So as a result, I put together this presentation about things that I think about all the time. My work in progress I'm working on is a communist space geologist who fights corporations and science. So, you know, spend a lot of time thinking about what are planets like way out, you know, in places we can't see. And so, the first thing I'm going to do is talk about why we should think about planetary science, geology, botany in world building when you're writing sci-fi. And this is a bias of mine that I want to talk about. I'm going to keep saying writing sci-fi. You might be making a sci-fi game, you might be directing a sci-fi short film. Whatever of those things that you're doing, all of this still applies because planetary science is the same. For me, it's going to be a shorthand to writing a book. So, no one throw tomatoes at me because I'm about to make fun of some well-loved fantasy and sci-fi properties. I love them too. Do not get me wrong. I'm a nerd. I'm up here talking about world building. I love this stuff, but some things in sci-fi and fantasy, speculative fiction in general, drive me crazy. So here are two maps from two well-loved properties, the Wheel of Time and the Sword of Shannara. I want to look at this map here a second, and I want to show you this perfectly rectangular mountain range that is obviously there because it's the edge of a sheet of 8x11 paper. This man, Robert Jordan, great books. I love the books. I started reading them in 8th grade when they came out. I think I've read every single one of them like within a week of it coming out. But that man could not draw a map. Like, this mountain range makes no sense. Here's the ocean. Here's the mountain. Storms are going to come this way. There's giant forests right there. We live in Oregon. We know what a rain shadow is, people. that mountain range, all of the rain's going to drop out there, and this is going to be a plain. That's going to look like Nebraska. Down here, we have Windbiter's Finger, which is a cool name, but, like, where did that even come from? Like, what's going on? Over here, we have Shannara, which, I apologize for this if anyone's not aware, spoiler alert, it's actually our world. I think that's like Missoula or something like that. So over here's the Pacific Ocean, here's a big pile of mountains, and there's some more forest sitting right in the rain shadow. Look, more forest sitting right in the rain shadow. Oh, let's look at this stream here. This stream, which is right next to this lake, starts in the plains, travels up into the mountains, and then back down into the lake that's like, you know, right there. There's no easier way for that water to go. It's good to think about geology when you're doing things like fantasy maps because we know what this stuff looks like, right? We know how this stuff works. These authors didn't do it. Oh my God, it's another rectangular mountain range. Where did this come from? Now, bless Tolkien, I love Tolkien. He's my favorite. I know that somewhere in the notes or in the appendices it says that the mountains around Mordor are either the Lamps of the Valar or one of the Maiar raised those mountains. But even in fantasy, I really don't like it when people say God did it. We're a science museum. We're talking about science here. God raised the mountains. Mountains, forest. And then we have the other side of the coin. We have Star Wars, which I of course love. No one throw tomatoes. Star Wars really loves planets with only one biome. We've got the swamp planet, we've got the forest moon, we've got Tatooine. So Tatooine, the desert planet, is actually an even better one because we know about a desert planet near us, Mars, and Mars famously has no oxygen because you need things to get oxygen, like, I don't know, green plants. So, you know, all respect to George Lucas. Man obviously has a lot more money than I'm ever gonna have. But like, Star Wars should have been 2 minutes long and it should have been Luke dying of oxygen deprivation. So, sorry about that. You know, the forest moon over here, like, you know, so maybe there's no mountains, so maybe the whole thing's a forest. But like, that really doesn't seem to make much sense. And I do know, I've heard a rumor that they made a 9th movie where there's an ocean on Endor, but that movie doesn't actually exist, so I will take no questions on it. Oh. So, all this to say, here's some examples of I'd like to see better science in it. Why is this actually a problem? So as a writer, you have a job. Your job is to make your audience suspend their disbelief. There are things that audiences know. Audiences know about rain shadows, audiences know about green plants creating oxygen. When you're presented with this as the consumer of media, it can take you out of it. Like, I can think of 2 examples in particular. I read a book where a piece of botany was so wrong that like I just stopped reading the book. I was like, I can't trust this author anymore. There was also a really cool Jurassic Park, like this was 65 million years ago. It was like a promo for one of their other movies. And they put a plant in there that evolved on an island called Socotra that has no dinosaurs and it didn't exist until 20 million years ago. And it was another thing where I was like looking at it, I was like, this is just wrong. That is Adenium socotranum. Those are dinosaurs, they did not coexist. You want to save your suspension of disbelief for magic swords powered by the Force, whatever that happens to be, or, you know, faster than light travel. That's where you want to save the disbelief. You don't want to be, you know, making your readers spend their disbelief on, you know, this oak tree is in the wrong place. So with all of this said, you can still do really cool and fun things. And one of the ways to do really cool and fun things is to realize that we all have some biases. And I'm going to talk about 3 biases in particular that we have, and they're not the ones that you're expecting. The 3 biases that we have, all of us, are an Earth bias, a solar system bias, and a time bias. So Earth is a really cool planet, and we all live here, and we are familiar with it. So when we imagine a fantasy world, what do? We imagine Earth. But it's fantasy. We can do different things. So let's talk about Earth bias and solar system bias here for a second. So this over here is my pointer. So this is what's called an accretion disk. This is what the solar system looked like before there were any planets. At the center is the sun. All these little track lines in here are planets, protoplanets that are forming. That's what it looked like beforehand. This is the pillars of creation. So it's a gas cloud, and they condense, part of the gas cloud will condense into this. And at that point, all these protoplanets are spinning in the same direction. So what that means is that every planet in the solar system is going to spin in the same direction, right? Everything spins west to east, the sun always rises in the east, the sun always sets in the west. I have never read a fantasy novel where the sun rises in the west. That's a bias. That's like something that we are biased towards because of that. But, so every planet in the solar system spins the same direction. So let's think about sci-fi, right? No, they don't. They did at first. All planets started out rotating in the same direction, and then space is a terrible place, right? So early in the existence of the solar system, Venus gets smacked by a planetary body that's so large that it flips it completely upside down. So Venus rotates west to east, or east to west. Sun rises in the west on Venus. It goes the other direction. Uranus is even weirder. It got smacked by something, so its south pole points at the sun. So it's rotating like this. So you wind up with, we'll get there. Something that's very common in the universe are what are called tidally locked planets. We have an example of one right next to us, the moon. The moon is tidally locked to the Earth. Its rotation matches the Earth's rotation. And this is another conservation of angular momentum thing. Gravity bleeds it off from one planet to the other. The top picture up here is a water world that was discovered with, I think, JWST, but it might have been Kepler. It's very close to the sun, it's tidally locked, so one side of the planet is always melted, one side of the planet is always a glacier. So that's a depiction of a planet that we discovered that's like that. So this is all to say, you can do these weird and cool things, and they're true to science, and you can make your worlds any way that you want it. Once again, seasons in fantasy books. Seasons in fantasy books are almost always the same length as seasons on Earth. They're almost always the same, but that doesn't need to be that way. Let's imagine our heroic pig farmer who's going to become a Jedi Knight. Let's think about him. Let's increase the tilt a little bit more, and then part of his hero's journey can be spending 6 months out of the year shoveling snow. Isn't that fun? It's great! If there's no axial tilt, there's no seasons. Everything's just the same. So you don't have to have seasons in your world. You can do whatever you want. And it's worth noting, I'm talking about these things, axial tilt. You're not going to talk about axial tilt in your fantasy novel. You don't have to. But if you put it in your head and you're doing this stuff in your head and you're working through this, then your book's going to be better because you've thought about all these weird things that you can do to your characters. And trust me, when you're writing a book or a video game, it's all about doing things to your characters. And man, look at that axial tilt. You imagine what the seasons are like on Uranus? Uranus. I always do that. There's my Earth bias showing. The seasons are going to be incredibly long, and it's going to be, I can't even figure it out in my head. It gets crazy. So here's another piece of Earth bias. Plate tectonics. We have plate tectonics on Earth. Of these 4 worlds that are pictured, Mars, Earth, Venus, and Mercury, how many of them have plate tectonics? Anyone want to guess? It's a good question. We don't really know. It's either 1 or 2. So we'll call it 1.5. Mercury definitely doesn't. Mars definitely doesn't. And Venus, since Venus is only a lovely place if you like 950-degree acid baths, spacecraft really haven't survived long enough on Venus that we know whether it has plate tectonics or not. Funny thing about plate tectonics is no one really knows why plate tectonics happens. There are some things that we do know. We know that you need a molten core of a planet. We think you might need a magnetic field for plate tectonics. We think you might need liquid water, but no one actually knows exactly why plate tectonics happens, and that's partially because we only have this one example. There are some interesting pieces to it, though. Venus does have mountain ranges, so that's going to take us on to our next one. If you don't have plate tectonics, you don't get mountain ranges because you don't have these big giant plates sliding into one another and colliding and causing mountain ranges. So Mars is kind of boring, but it does still have surface detail. So you can take your planet and say, I want my planet to not have plate tectonics. And let's see what that's gonna do. So if you want surface detail without plate tectonics, you still have volcanism. There are volcanoes on Mars. That still happens. Asteroid impacts lead to some really big structures, physical structures on Mars. And erosion, mega floods, much like the one that formed the Columbia Gorge. Mega floods were very common in early Mars's history. So you can still, without plate tectonics, have an interesting physical world. And then you get to something really cool about the lack of plate tectonics, and that's volcanoes. So these are both volcanoes, one on Earth, this is Hawaii, obviously, and this is Olympus Mons on Mars. So both of these are hotspot volcanoes. Basically, there's a mantle plume coming from deep in the mantle, it's ejecting magma upwards, and it's forming a volcano. When you have plate tectonics, the crust of the Earth is sliding over the top of that hotspot as it stays in place. And so you wind up with multiple volcanoes like this. Mars doesn't have plate tectonics, so you get one giant frickin' volcano instead of an island arc like Hawaii or an arc of volcanoes. So if you're writing your fantasy novel and you're like, you know what I really want to do? I want to make my characters climb the tallest thing anyone can imagine. Get rid of plate tectonics. You can have a giant volcano. Like this thing, that's the size of Arizona. So this is where we're going to find out if I can condense 14 billion years of history down into 2 minutes. This was a problem in my initial set of slides. I talked about this way too long, so I'm a total dork. That's going to be mineralization. So mineralization is interesting. Basically, in the accretion disk that formed the solar system, there were only about 60 minerals. We know that because of Klondike asteroids, where there's an example of one up here. What a mineral is it's basically a stable chemical compound of known properties that crystallizes. So things like ice. Ice is a mineral, most common one you'll see. It didn't exist in the protoplanetary disk that formed the solar system. And this is just a fun little side point. I hate diamonds as a rockhound and a geologist. They're really boring. But diamonds are just carbon, and they form at high pressures. So most likely, diamonds were the first mineral that existed in the universe. So that's cool. There's finally something special about diamonds. Once a planet's cool, you get igneous forces developing, and igneous processes are ejecting. You get a cool crust, and stuff gets ejected from the center of from the core up, or from the mantle up into onto the surface. So when that's happening, a lot of things are happening. It's the first time really that you have non-extremes. In the early universe, all you have is the center of a star and cold space. You don't have anything in the middle. When a planet's forming, you finally have middle grade temperatures and pressures. So you form all sorts of things, including some really cool rocks that we call pegmatites. Pegmatites are a form of granite, and they're basically, they're where you find large crystals like this aquamarine or this smoky quartz. So these are developing maybe 3 billion years ago. And for planets that are low in volatile chemicals like water or free oxygen, well, we'll get to free oxygen, but so Mercury and the Moon have about 350 minerals total. At this point in the Earth's evolution, there's about 550 minerals. Then, oh my God, coming over the rope with a folding chair, it's plate tectonics. Plate tectonics happens, and as that happens, you start cycling minerals back down into the crust, and you're carrying water down into the crust as well. This leads to an explosion of mineral species, and to a lot of the economically important compounds like gold and copper. As it cycles back in, wow, I am going real slow. As stuff cycles back in, it gets concentrated. And then life happens, and we go from about 1,500 mineral species to the 5,500 that we know today. The Great Oxidative Event is the biggest driver of mineral species and mineral evolution that we know of. So, your desert planet that doesn't have any green life, if your main character is a geologist and not Luke Skywalker, he's going to be really bored, and then he's going to die very quickly. How will minerals evolve in the future? Well, that's a good question. We live in the Anthropocene currently. The Anthropocene is an argument, not a geological age. That's basically humans are here. And we're making all sorts of cool stuff. We make plastic, we make carpet, railings, all these things that we're making, they're eventually going to get recycled into the Earth by these crustal processes that I've been talking about. What's going to happen to all those novel compounds when all of these planetary forces start acting on them? No one really knows. So it's cool that we're, living in a experiment, but also you're writing your sci-fi. There was an alien civilization on this world, 30 million years ago. What's happened to all the weird stuff that alien species made that's now getting cycled back through? You can play around with all sorts of stuff to make all sorts of things that we've never seen before using the things that we know about. So, when geology gets weird, biology gets weird. You don't need weird geology to get weird biology. I'm going to do this real quick because it's going to be obvious I don't know what I'm talking about. But this is Mono Lake in California. Mono Lake is a very shallow, extremely saline lake. One of the coolest things that I am aware of in the diversity of Earth life is that there is an arsenic cycle in Mono Lake. There's enough arsenic there that bacteria have learned to use it in place of the magnesium that plants use for chlorophyll and the iron that we use for in hemoglobin for energy transport and energy storage and all that. And microorganisms trade arsenic through different reduction states in there, which is just mind-blowing to me. Like, look it up, it's dope. But you don't need weird geology for that. So we're gonna sort of slide into our botany here a second. We're gonna ask the question, what's a tree? And I'm gonna make the argument that there is no such thing as a tree. There's of course there's such thing as a tree. But when we think of a tree, we think of this here, this big oak-looking thing here. That's not the only kind of tree that there is on the Earth, obviously. There's pine trees too. No, not pine trees. Trees are a strategy that plants evolve. Trees evolve, and then those trees evolve back into bushes all the time. There's blueberry trees. Almost any plant species that you can think of, there's almost always a tree form of it. So here's two examples of not like weird geology causing trees, but this is a tree fern. It's from New Zealand. It's nothing like a tree that we're used to. In this case, the entire tree is dead. Only the very top fronds and the crown are alive, and it's sending rhizomes down through its dead trunk into the ground. And that is an evolutionary strategy that it hit upon and did that, and it's really cool. This guy over here is a Dendrocyckius socotrannum. I love the biology of the Socotra Islands. It's really cool. This, of the 950 known species in the cucumber genus, this is the only tree form. That is a cucumber tree. It makes cucumbers that you can eat. Biology just did that. It was like, you know what? You know what's a good survival strategy for me? I'm gonna make a tree. Trees happen all the time. So you can, anything that you're thinking about, like there are tree dahlias, it's crazy how many different kinds of trees there are. So when you're thinking about populating your world, whether it's Earth or it's a sci-fi planet, or fantasy world, you can make anything a tree. Make a tree out of geraniums. I don't care. You can do that. It can work. It can happen. So these are some pictures that I took, and I'm going to talk about biological diversity in places. So all three of these places are a desert. That's me over on the left. I had just collected a 50-pound obsidian. It was pretty cool. This is in Beatty's Butte. That's a desert. This is Southern Oregon. This is my lovely partner in Moab, Utah. That's a desert. And then over here, this is in the John Day Basin. This is a volunteer thing that I did. That's a desert. You can have life in deserts, and you can have really green and really flourishing life in deserts around water holes, riparian zones, streams. You can take anything that you're any biome that you're gonna talk about, you can find examples on Earth of exceptions and that are really cool and can lead to really cool scenes or settings for you to drop your characters into. So that's an example of deserts. Let's talk about forests. Is it a West Coast forest or an East Coast forest? Maybe it's a European forest. West Coast forests are super cool and kind of boring. I know, I'm a terrible, oh, is this when I get the tomatoes? I thought it was going to be Star Wars. West Coast forests are awesome. I love going hiking through West Coast forests, but there's a relative paucity of species in any given place compared to the East Coast, where the plant life is much more diverse. So depending on where your setting is, your characters can be encountering different things. And it's worth thinking about this when you're writing so that you can have your characters experience things and have it be realistic. And then we're going to get to serpentine soils, where lots of the weird stuff in the world happens. So this is from the Climates, and this is just a really weird fritillaria. This is from New Guinea. This is an aquatic conifer, the only one that I'm aware of. These are plants that exist, and they exist in serpentine soils. So serpentine soils are very high in heavy metals. This means that a lot of plants can't survive well there. When a plant moves into a serpentine soil, if it happens to survive, it'll often thrive in that place and then expand inside it, and you get big speciation events of weird stuff. You can see this. The Climates are an island arc that got slapped into the North American plate, and there are multiple places down there where there will be a single hillside that has a species on it that is endemic to that hillside, nowhere else. So you can, when you're writing, if you want your characters to be like going through a real unique place, think about serpentine soils and look into places like California, the Climates, New Guinea, Socotra, places where you have a lot of diversity. Let's talk about post-apocalyptic fiction. How badly have humans messed things up in your world? This is the time bias that I was talking about, and specifically I want to talk about what's referred to as shifting baseline syndrome. What shifting baseline syndrome is it's the tendency for humans to think that it is always going to look like, it has always looked like what it looks like now. So, you know, we think the number of birds in the sky that we're used to is normal. If you go back 100 years, passenger pigeons used to fly in flocks so large they would blot out the sun. They were killed. We did it. Some of it was accidental, or some of it was from hunting, but most of it was because we introduced chestnut blight. We took out all the chestnut trees. The chestnut mast was their main food source, and all the passenger pigeons died, and now they're extinct. It doesn't have to be accidental like that. Oregon's the beaver state, but there used to be thousands and tens of thousands of beavers here, except we let the British know that they had 10 years. And all the fur trappers who at that point had been working in Oregon and trapping at a sustainable rate were like, well, they're kicking us out, so we're just gonna get them all. Beavers almost went extinct, fishers did go extinct, sea otters went extinct due to over-trapping. And then you have just humans being nasty, and you know, in the mid-1800s, the US government saying, well, we really want that Native American land, and they eat those bison, so if we kill all the bison, it's going to be easier for us to take that land. There are all sorts of ways in which humans have impacted the world, even things like roads. Roadkill is crazy. Roadkill will eventually empty a pond of frogs or amphibians. There are documented examples of species that are endemic to the roundabout outside of highway exits, where just having that road for cars to get off the highway traps a species of beetle inside that little piece of land, and that is a genetically distinct population all of a sudden. So this is going to be my example, and I hate this, but this is what I think of when I think of an elephant herd. This is an elephant herd today, give or take, size of one. I would like everyone to just take a second and think of what you think an elephant herd in the 1970s looked like. That's shifting baseline syndrome. So think about that when you're writing either, if you're writing historical fiction, there should be a lot more critters. If you're writing post-apocalyptic fiction, there's going to be a lot more critters. There are no more cars, there's no more roadkill, there's no more humans, there's less humans to take things out. I love the Hunger Games. I love the Hunger Games as much as everyone. District 12 is all of West Virginia. It's got one town in it. They should be swimming in deer. I can't. This is technically half an hour, so Lexi, if you want me to stop. I'm close to done. Okay, I'll do 5 more minutes. Thank you, Lexi. I appreciate that. Sorry for talking so long, everybody. If anyone wants to leave, please feel free. So how else have humans impacted the environment? These are 2 examples from The Last of Us, which I love. You know, we've got the invasive fungi that kills everyone. So that's something we did. We transported that in. But we also let the animals out of the zoos, and now there's wild giraffes. I just think it's just awesome. It's lovely. So, what's the best way to learn more about all this? These are some examples of some books that I really like. Roadside Geology in particular is awesome. They make it for every state, and you can drive and read about the geology. It's down to like what road you're on, so there'll be like a chapter for Route 26, a chapter for I-5. Wildflowers of the Pacific Northwest is great. And After Man and The World Without Us are both very interesting, very science-based explorations of what the world may look like later on. My favorite way to do this is to go and experience it. I volunteer a lot with the Oregon Natural Desert Association. It's great. It gets me out into like places 30 miles deep, 30 miles from pavement, and you're working with people who are really passionate about it and spent their entire lives learning about these ecosystems. It's super cool. Some books up here, and a show and video game that I really liked. I thought they were really good examples of world building. We Are Legion, We Are Bob effectively has no plot. It's effectively just world building. So if you want to see someone really dork out, N.K. Jemisin is fantastic if you haven't read her. World Building and For All Mankind is great. Ditto Last of Us, and Wayward is a good recent post-apocalypse. And finally, the best way to learn about anything. If you ain't falling down a Wikipedia rabbit hole, I don't know what to tell you. And I'm going to end talking about this with something that I have to remind myself all the time. I am not just choosing violence against you, I'm choosing violence against myself. This is my last thing to say about world building. Thank you so much. Does anyone have any questions?
You mentioned serpentine soil. I'm curious about what are the characteristics, the qualities of what is serpentine soil?
So serpentine soils are created when ocean bedrock, so the basement rock of the ocean, gets kicked up on top of the continental shelf. And because it's been down there, it's been metamorphized so many times, and a lot of times it's been recycled through the crust, the heavy metal content is very high. There's a lot of tin and a lot of iron, and it's toxic to a lot of plants. It's also toxic to humans. There are times in California where you're recommended to stay inside because there's so much dust blowing due to agriculture having really mobilized those serpentine soils. Serpentine is a type of rock also, which is where the name comes from. They're really cool. Look up the plants that grow there. Plants that grow well in serpentine soils also grow really well in normal soil because they're so tough. So a lot of our more interesting decoratives were originally from serpentine soils.
What's your favorite plant?
What is my favorite plant? Well, oh gosh, that's so hard. One of my plant projects is I'm trying to develop a Portland hardy avocado, so I have 43 avocado trees in my driveway. You may notice that I got obsessive about things. I was talking about the Adenium stocatranum, which is also called a desert rose. I think they're really cool. I love caudiciform plants with the little fat trunks and the little spindly. They're so cool. Caudexes are water storage bodies that looks like trunks. but aren't technically trunks.
What kind of world building would you consider Pierce Anthony?
Oh, God. For 12-year-olds in the 70s? I don't know. Piers Anthony's tough, man. I haven't read any Piers Anthony for a really long time. And I remember being a little squicked out by it when I was like in 10th grade, so I don't know. I don't have a good answer for it, I'm sorry to say.
What do you feel about The Martian, where it's like known for more of the science side of sci-fi?
I love The Martian. I think it's really well done. I think he does a good job with the science. He does a really good job making it funny, which, you know, I tried. I don't know if it really worked, but I gave it a shot. Books like that I recommend. So the Dennis E. Taylor that I mentioned, there's a lot of good science in there. Even though, again, the plots are weak, but he does a good job with the science. Characters are kind of weak too. What's another one that's like The Martian?
More sci-fi with reason, with biology, with science.
You know, I'm actually not going to recommend sci-fi. If you really want a good book with botany in it, The Overstory, if you haven't read that, The Overstory by
Richard Powers.
Thank you. Richard Powers is a mind-blowing book. Just amazing. Like, the trees are as centered as characters as the people are. It's gorgeous. I also might recommend my book, which there's a lot of science and biology in, which is Post-Apocalyptica set in Philadelphia. So if that's something that you like, lots of science in there. Not as good as The Martian. Okay, well, any other? Oh, wait, one more question. Awesome. I've already talked too long, but Lexi's being so kind. On the world building in Star Trek. I usually like the world building in Star Trek. I think it's usually pretty fun. They always pick plants that look alien, but it's like, oh, that's a Bhutan citrus. Like, I know exactly what that is. Or that's a horned melon. Like, you're watching it, and they're picking all this weird looking stuff, but it's like, oh yeah, I used to get that at Kroger's when Kroger's was still around. So that part's funny, but I usually like the Star Wars world building. And also, because it's so episodic, they tend to go to one place in a lot of the planets. So they don't really say things like the forest moon of Beta Pixis or whatever, which I appreciate about Star Trek.
I just wanted to hear a little bit about your book. Pick it up with something that...
Yeah, I would love to. So it's called The Fork. I was reading a lot of Borges at the time. I originally called it The City of Forking Paths. Shortened it. It is a book about a group of teenagers who decide that they're living in Philadelphia and their compound gets raided and their leader gets killed. And they decide that rather than having another leader, they are going to draw on Quaker traditions and anarchist traditions to try to instead of having a leader, we're going to have a flat society and we're going to, decide everything is equals. And how that alternatingly goes well for them and then goes really not very well for them when a sort of capitalist-esque group comes into town. So there's a lot of, I'm very concerned in the book about, how do they actually make it through the winter? So there's a lot of talk about the plants and how they're preserving food. There's a bit of it that gets a little, I've been told I might talk about making jam too often. But it's really important if you're trying to preserve fruit for the winter. I'm sorry, guys. And so the two main characters the book follows are Freeman and Molly. Molly is really the heart and soul of the book, if you ask me. And Freeman is the narrator, and well, sort of narrator, but it really is, it's everything either from his point of view or adjacent to his point of view, and he is effectively the first engineer, so he's in this post-apocalypse, so he's doing things like getting record players working, getting sewing machines working again, taking three broken things and making one whole thing out of it. So, thank you, I appreciate that question. Okay. Well, I have talked way too long, so thank you all so very much, I really appreciate it. I have to do one thing, because every time I go see a band, they do the thing where they do the selfie with everyone behind them. So I gotta really get dorky here a second. Yeah, say hi everyone! I think that worked. Yay, thank you so much!